Danai Dima. I'm based in London, in City University London and at King's College London. And I'm leading, or co-leading, with Professor Sophia Franke at Mount Sinai in New York, the ENIGMA Lifespan group, which has to do all with from 2 to 92 years old, how your brain changes. Traditionally, especially in the medical profession, the professors would decide. They would be the names that would lead everything, and then for the younger people, where I count myself also in, would do the actual work. But the ENIGMA has done that upside down. So actually, you co-lead with older people, but you get the credit for it. And it has an amazing also gender balance, which we don't see at all almost in any medical again. So it has a lot of good things. They're young, they're women, and everyone is happy. No one will think less or more because who you are or where you come from.
The first reason why ENIGMA is great is that it enables us to have really the sample size that is, I believe, that will be required to find any significant result in terms of DNA methylation in the brain. ENIGMA has gained a reputation now. You know, it has really delivered. They are the first publication, and people have seen that by working together, there are fruits. So the outcome and the output is really, really big, and it's getting more and more. And this is a very good incentive for people to say, okay, I cannot achieve that by myself, so let's go and work together.
ENIGMA is a unique resource when it comes to understand how genetic variation or genetic factors influence brain structure, both in a cross-sectional way but also across the lifespan. That is obviously really important because disorders develop in a developmental context and are also subject to different environmental influences over the lifespan. So having a data set which allows the generation of robust results in these areas just gives you really, really good starting points, you know, for further mechanistic analyses.
I think ENIGMA is the best example of how researchers can work together. I always give this as an example of this new kind of working in science, and I think that apart from the numbers, because you need the power, statistical power, so that's I think one great advantage. Finding that if you do large meta-analysis, we find that some of the studies that have been smaller in fact do show what the meta-analysis also shows, which is very reassuring, a validation of what earlier work has been doing. So that I think is also very helpful.
Advantage with ENIGMA is that the data has been collected with the same protocol, both for imaging and genetics, and they have the pipeline for big data, generation and storage and all that thing, and then also the atmosphere. I think ENIGMA is very collaborative. Everybody wants to participate in this, and it's been a very exciting process, and a lot of collaborations and scientists all over the world who want to join and take part in this. So I think it's very the kind of scientific collaborative atmosphere has been great.
We approached the community under the banner of ENIGMA, and I think we really had a fantastic, very, very positive response because ENIGMA has such a strong reputation. It has already led the way in imaging genetics and then in psychiatric large-scale imaging. And I think people were really keen to get involved because they knew that ENIGMA is associated with success in these kinds of studies.
I would agree. I think people understood that working with ENIGMA would make it much more likely this kind of study would succeed, would lead to findings that were credible and that are biologically important.
Through the name ENIGMA and what we've done before with ENIGMA, we've really shown that this is a worldwide collaboration. We've established that there is a small threshold in getting into ENIGMA because we don't require people to really give their data. On the other hand, of course, the sharing of protocols, the infrastructure and the protocols, that is, and the help that you can get in analyzing data.
for me as a Parkinson's researcher, ENIGMA offers tremendous kind of support and streamlines the analyses that we can do with those done in many other disease groups, and we can do cross-disease comparisons, which I think will really be beneficial and advantageous in really understanding what is going wrong in Parkinson's disease, at which state of the disease do certain deficits occur. So I'm looking forward to what ENIGMA has to offer and what we can in return offer ENIGMA in terms of neurological disorders.